This is Math 102, Section 12.2. Going to be working on solving some more systems of equations. The previous section was solving systems using graphing. This is going to be using the substitution method. There is a third method that we'll look at in Section 12.3. The substitution method is exactly what it sounds like. You're going to substitute one thing in place of another. What we're really doing is we are taking these two equations, kind of combining them together so that we just have an x or we just have a y, because we know how to solve an equation that has one variable. In this situation here, using substitution, we see that y equals x plus 1. So I can take this x plus 1 and put it in place of the y right there. So what I'm looking at is 2x from this equation plus 3. And then in place of the y, I'm going to substitute this other piece. It's still going to equal -2. So this x plus 1 is going to go right in there. All right, so in place of the y, I've put x plus 1, substitution. Really important to put those parentheses to remind you that this 3 is times the x, and the 3 is times the 1. So I'll have 2x plus 3x plus 3 is -2. I'll combine my like terms together. 5x plus 3 is a -2. I will subtract 3 from both sides. 5x is a -5, and when I divide by 5, I get x is a -1. Now remember, a system of equations is two lines. We're looking for where they cross, if they cross. So not only do we need an x value, we also need a y value. I'm going to take this value that I got right here, this -1, and put it right back into that. So y equals -1 plus 1, which is 0. So my ordered pair here is -1, 0. That's the solution. That's where these two lines cross each other. If I'm looking at this next one, I'm going to change colors so you can see the difference here. This is already set up very nicely for substitution because it says x equals. This other one said y equals, so it was set up easy to substitute. So this 3y minus 1 is going to go here in place of the x. Again, be careful that you've got parentheses around that. So I'm going to put that 3y minus 1 inside the parentheses because it's taking the place of the x. The entire part of it has to be multiplied by 2. So I'm going to distribute, and I'll get 6y minus 2 minus 4y equals 2. Combining like terms on the left-hand side gives me 2 minus 2 equals 2. When I add 2 to both sides, I get 2y is 4, and dividing by 2 gives me a y of 2. That's my second number of my ordered pair. Then I'll take that number, I can put it back in either equation. It's easier to stick it here. So I can say x equals 3 times 2 minus 1, so I get 5. That's the idea behind substitution. These two first examples, they already had one equation that was set up that made it really easy to substitute, where we had x equals or y equals. That is not always going to be the case. Sometimes we are going to need to rearrange one of them. Here we have 3x minus 2y is -7, and 6x plus y is 6. Neither of them say x equals or y equals. But remember, we can rearrange equations. So I'm looking for the term that has a coefficient of 1, because that'll be the easiest one to rearrange. And I see that right here. This has a coefficient of 1. This is going to be really easy to rearrange so that it just says y equals. I can do negative 6x plus 6 or 6 minus 6x. It doesn't matter which way. And then I will take this, put it in the other equation in place of the y. So I'll have 3x minus 2, and in the parentheses, I'll put this entire piece, equals negative 7. Distribute, being very careful with your signs. Got 3x. Negative 2 times 6, negative 12. Negative 2 times negative 6 plus 12x equals negative 7. Negative times negative is a positive. Combine my like terms of 3x and 12x. 15x minus 12 equals negative 7. I will add 12 to both sides. I'm trying to get the x by itself, right? So I get 15x equals 5. Now the answer is not 3. I have to divide by this coefficient. So I have to divide. This is why it's important to show this step, so that you can see that this is 5/15, which simplifies to 1/3. So my x is 1/3. I need to take that and put it back into one of the equations. So what I'll do, I'm just going to pick the first one. 3, now x is 1/3, times 1/3 minus 2y is a negative 7. Well, 3 times 1/3 is 1. Minus 2y is a negative 7. If I subtract 1 from both sides, I get negative 2y is negative 8. When I divide both sides by negative 2, I get y is 4. Okay? That's the big thing for this lesson, is this substitution. This next box tells about situations where we have parallel lines, no solution, inconsistent, independent. And we have lines that are the same line, meaning they are consistent and dependent. So it shows you what's going to happen, what it will look like in those situations. Here, you get this contradiction when you get something like 0 equals negative 3 or 12 equals 6. That means they're parallel and there's no solution. But if you get 0 equals 0, 12 equals 12, that means it's an identity. It means they're the exact same line. So a couple of different words here than what we've used with consistent and inconsistent, dependent and independent. We have a contradiction and we have an identity. Identity means they are the same line. There's an infinite number of solutions. They are consistent. They are dependent. Lots of different words to describe that situation. Let's look at how that'll play out here. This already says y equals 5x plus 11. So I'm taking that and putting it in place of the y. Once you've substituted, you should only have one type of variable in your equation. So I'll have that 4x plus 12. But in place of the y, I'll put 5x plus 11. Now I'm going to distribute the 12 times the 5x and the 12 times the 11. The 4x is just going to sit there a minute. That's going to be 60x plus 132. Notice a lot of these steps are the same after we've distributed. There are some like terms to combine together. And then there's this number to subtract from both sides. So I get 64x equals a negative 128, because 4 minus 132 is a negative 128. When I divide both sides by 64, I get negative 2 for my x. So everything didn't cancel. I don't have either one of these situations right now. I get negative 2 for x. When I take that negative 2 and put it back here, I use the second equation because it already says y equals. So I'll have 5 times negative 2 plus 11. which is a negative 10 plus 11, which is 1. So my ordered pair answer is negative 2, 1. Now let's see if the next one is like that. Let's see if the next one gives us one of those unusual situations. We have a system here. Neither of our equations say x equals or y equals. However, this has a coefficient of 1, so it would be a fairly simple thing to rearrange this one so it's equal to x, to set it equal to x. So if I have that x minus 3y is a negative 3, adding 3y to both sides gives me a x equals situation. Then I can take this 3y minus 3 that is the same as x, it's equivalent to x, so I can put it in place of x. Make sure you put it in the other equation, otherwise it won't work. So I'll have 2 times 3y minus 3 plus 3y equals 3. Let me distribute. 6y minus 6 plus 3y is 3. I'm going to combine my like terms. I'm going to add 6. Like I said, hopefully we're getting to the point where this actual solving can go kind of quickly. I got 1 for y. When you're watching me do this, stop the video right in here and say, let me see if I can solve that myself. And then start it again and see if we get the same answer. If y is equal to 1, I can put 1 in either of these places. Let's put it, I'm going to change the color so you can see that back substitution. I'm going to put 1 right here. 2x equals, plus 3 times 1 is 3. 2x plus 3 is 3. And when I subtract 3 from both sides, I get 2x is 0, so x is 0, so my answer 0, 1. Well, they did this thing up here in the yellow box. Made me think that one of the next 2 problems was going to be inconsistent or dependent or no solution, and neither of them were. Well, that must mean the next ones are going to be like that. So let's have a look at them. Got a number of them here to look at. All right, this one already has y equals. Very nice. So I'm going to take this, even though it's a fraction, and I'm going to put it right there. So I'll have x minus 4, and instead of y, I'm going to put 1/4 x plus 3 equals 8. Don't forget that everything in that equation will stay the same, except that the y is replaced with the 1/4 x plus 3. Let's distribute. 4 times 1/4 is 1. So I get a minus x. Negative 4 times 3 is a negative 12. What happens to my x's? X minus x cancels, don't they? And I'm left with this negative 12 equals 8. That is false. That is a contradiction. There is no solution. We could say the lines are parallel. We could say they are, what is it if they're parallel? Inconsistent, and they are also independent. Lots of different words we can use, I-N-D-E-P-E-N-D-E-N-T, independent. This next one, I have negative x plus 4y is 10, and x equals negative 2. Oh, this is kind of nice. I'm just going to put negative 2 right there where the x was, because x is negative 2. I already have my x value. Now, when I put it in here, I've got this negative that's on the x. So there's the negative that's on the x. In place of the x, I'm going to put negative 2. Plus 4y is 10. Do you see why both the negatives are there? This is saying the opposite of x, whatever x is. The negative of whatever x is. So this is going to be 2 plus 4y is 10. I'll subtract 2 from both sides, getting 4y is 8, dividing by 4, y is 2. Now let's talk about this next one, because none of those 4 terms look very friendly, do they? This is not one that I would probably solve using substitution. And when we get to the next type of solving with elimination, that might be something we do with this. If you tried to solve either of these for x or y, you're going to get a fractional answer. So what I would encourage you to do before you start in on your homework for 12.2 is to go ahead and watch the 12.3 video that'll be coming along with this and see if there's another way that'll be easier to work this. I'm going to come back to this one and work it when I have a little more room at the end of the page. Here, I've got this 3x minus y is 7. Is there a way I can rearrange that so it says y equals? Well, I can move the 3x over, right? And on the right-hand side, I would get 7 minus 3x. What's on the left-hand side? What am I asking you to be careful about? Negative, I'm going to put a 1 there, y. Haven't solved for y yet. I need to divide everything by a negative 1. It's going to change all my signs. So I have y equals negative 7 plus 3x. Now I'll put this right there. Okay, so this was me solving for y so I could substitute. Then I'll have this second equation, negative 14 plus 6x equals 2 times negative 7 plus 3x. Let's see what happens when we distribute. Anytime you see parentheses in these, you have to distribute. That has to be done first. So negative 14 plus 6x equals negative 14 plus 6x. Look at the two sides of this equation. They're identical, aren't they? If I start by subtracting 6x from both sides to solve this, I get negative 14 equals negative 14. That means that these two equations are identical to each other. They are the same line. We say it's the identity. They are consistent and dependent. There's some good examples of doing this, of working with this and solving using substitution. I do want to look at these few word problems down here at the bottom. The key with these word problems is setting up your two equations. You know that you're going to have two equations with x's and y's, and you're having to write the equations. Once you set them up, solving them, use whatever method you want. This says one number is 3 more than 4 times another. When it's just talking about a number like this, we're just going to do a excuse me, word for word translation. One number, we're going to call it x, is would be equals 3 more than is 3 plus 4 times another, and that's our 4y. That's our first equation. Usually one sentence is one equation. The second sentence says their sum is 133. Their sum is 133. Sum is what we get when we add two numbers together, right? X plus y equals 133. How are we going to solve that? Substitution. We'll take this 3 plus 4y. We're going to put it right there. So I'll have 3 plus 4y plus y is 133. Let's stop the video and solve it. 3 plus 5y is 133. Subtract 3. Running out of room. 5y is 130, and if I divide both sides by 5, I get 26 for y. And then I would go back and find out what x is, because they're going to add up to 133, right? So I would do 133 minus 26 is 107. Let's look at the next one. The sum of two numbers is 956. I like those equations. One number is 94 less than. Be careful with the phrase less than. This means you are subtracting 94 from something. 94 less than 6 times the other. I'll let you solve it. There's your two equations. Two angles are complementary. You've got to know what this word means. What does it mean if they're complementary? It means that when you add them together, you get 90. See them right there? One angle is 30 more than twice the other. See how I'm writing the equations? There's your two equations. Two angles are supplementary. That's a different word. What does supplementary mean? It means if you put them together, they make a straight line. It means that when you add them, you get 180. One angle is 5 less than, subtract 5. Less than what? Twice the other angle. In a right triangle, one of the acute angles is 9 less than twice the other. Let's start with that. One of the acute angles is 9 less than twice the other. It doesn't seem like it gives us anything else, except the fact that it's a right triangle. A right triangle has an angle that is a right angle. It has an angle that is 90 degrees. The whole triangle, all three of them, add up to 180. That means that this angle here and this angle here must be complementary. They must add up to 90 as well. Two positive numbers have a difference of 8. So when I subtract them, I get 8. Now, look at what happened here. They're positive numbers. When I subtract them, I get 8. The way I wrote this, which one is larger? Because I get a positive answer. This is the larger one, right? Larger minus smaller. So x is the larger number. The larger number is 2 less than, subtracting 2, 3 times the smaller. And I know the challenging part here is the writing of the equations. Once you've gotten them written, the solving is not too hard. In a right triangle, it's a right triangle, so these two angles are going to add up to how much, right? One of the acute angles is 20 less than the other. And because they're the two acute angles of a right triangle, we know they're going to add up 90. The other things that are in this homework are reviews of factoring, more review of factoring. There is only one topic in the 12.2 homework on substitution. So you're only going to have a few examples of these to do. You may or may not hit some word problems when you get into there, but hopefully this 12.2 assignment will not be too tough. Again, go ahead and look at the 12.3. It doesn't matter to me what method you use when you're solving these.